In part one, we looked at the start of the tunnel's construction. So what does it take to build a tunnel that can support the multi-storey developments planned for above ground? Literally laying the foundation for Perth's growth. The cut and cover tunnel involves piling more than 41 metres below ground into the Kings Park rock formation layer. Due to the sandy soil, high water table, existing twin-bored Joondalup Line tunnels and strict loading requirements, the 600-metre tunnel sees a number of different piling and grouting techniques used. In this Behind the Hoardings, we look at board piling and diaphragm walls.
The first works that happen are the piling works, and it's all the subsurface activities that we don't really see. They generate quite a lot of mess out there in the field. The challenge there is keeping the place tidy and keeping it safe. And then gradually the structures will appear up out of the ground, and we'll start to see the shape of the covered structure that will eventually house the railway lines.
Starting at the Milligan Street end of the site, known as the Western Decline, are 150 board piles, selected specifically as the piles' size and depth to 41 metres make them capable of supporting the load of future buildings.
The purpose of these piles is to be able to take the load that's going to be placed on them later. The piles are coming close to 40 metres in depth. This is what's called board piling. Basically we just have a rig, as you can see behind me, that has a bucket type attachment on it, and it digs down, pulls the dirt out, and then we put fluid into the hole to stop cave-ins from occurring. Then we put a steel cage down the centre of the hole, pour concrete, and as the concrete's coming up, it displaces the fluid that we pour into the hole, and it gets retreated so that we can use it again for the next hole.
Due to site constraints, the load testing of the board piles has been carried out using Osterberg cell or O-cell testing, rather than the usual Kentledge load test.
A couple of the piles that we've put in, they have a cell placed a certain way down the pile, which is 2 plates, roughly 1 metre apart, and they have a hydraulic system that forces pressure on the piles to know that they're strong enough without breaking, and they can take the load that's going to be placed on them later on.
Working in a live operating environment posed some challenges. That's why piles located next to existing structures were installed at night under rail isolation.
You can see right up in the distance there a piling rig which is working in very close proximity to the live rail lines there. One control we've introduced there is that the man spotting the infrastructure for the rail actually has a stop button to stop the crane and the piling rig if he deems it getting too close.
From the Western Decline, the main tunnel begins. This sees the Fremantle Line completely underground from Lake and King Streets to William Street. This section of the tunnel is made up of 152 diaphragm wall panels, which were installed by October 2012.
On completion of the diaphragm walling in the main section here, we're just moving into a phase where we're starting construction of what we term the main tunnel, which in truth is some concrete walls with a roof which is added. Now we're constructing the roof before we complete most of the excavation, a process called top-down construction. We put the roof on, and as I say, then we dewater and we excavate down below the water table. When we get down into what we call the formation level, we'll construct the in-situ reinforced concrete base, pour concrete on that with a waterproofing layer in there, and incrementally we build the length of the new alignment of what will become the Fremantle Tunnel.